Welcome to this tutorial. In this tutorial we are going to train on how to troubleshoot. We are going to troubleshoot SIP audio issues on a SIP trunk. The issues that we can face are no audio both ways. Or number two, you can have one-way audio. One part can hear the other part, but the other part cannot hear the other part. Or we can have a choppy audio. So these are the scenarios where we need to troubleshoot, and we are going to look at the causes and the possible remedial actions. So let's lay the foundation for what we are going to discuss here. We are going to start So we are going to have a Mitel phone here. For example, this is our telephone. When it calls out, this is the number that it is going to use as the calling number. This is its calling number for caller ID, and it's going to call somebody who is outside of the organization on this number. So this is the called number. This is the calling number. The calling number is also known as, and the code number is also known as, the Dennis. So you must research these terms, Annie and Dennis. I will refer to these names also in our tutorial. So what's going to happen is that this user is going to pick up the phone, and this user is going to initiate a call. Let me use this blue color. He's going to initiate a call. He's going to tell my voice business that he wants to make a call, and my voice business is going to send an invite to this guy. We are going to ignore the leg where the provider sends the invites through to the called number outside. So this is going to send an invite, a SIP invite. So the call is comprised of two things. Number one, a SIP leg, which we shall call, which comprises an invite, and number two, an RTP leg, which carries the audio. So the SIP leg is responsible for setting up the call and for tear down. So the SIP invite can be successful, and then when it's successful, the RTP leg can fail. So when the RTP leg fails, this is when we are going to experience audio either one way or both ways. So let's look at this further. When the user here dials this number 73831039, which is this number here, they are going to send an invite where the IP address of the My Voice business is going to be the from IP address. Let's say this IP address, and then it's going to carry a 2, the IP address of our provider. So it's going to invite 73 Okay, let's just take a step back and have a relook at this. This user is going to make a call. Let's just say this dials 73831039. When he does this, the controller is going to send an invite 73831039 to the provider. Then the provider is going to extend the invite to the actual user. When the invite is successful, the provider is going to send an SDP, which we call a session. SDP means session description protocol. So in this invite, there is also an SDP. This SDP is going to state the codecs that are going to be used, and it's also going to state, okay, number 1, codecs, and number 2, RTP ports. So in the codecs, it's going to send a list of codecs in the invite to say, maybe I need to talk to you on G711 ALO or G711 YOLO, depending on what you have configured to be sending the invites in the SDP. So G711 is also known as a PCMA, also known as PCMU. And the RTP ports probably is going to say, because Mitel, the RTP ports range is from 50,000 to 50,511. So it's going to say probably you are going to use the first port, probably let's say 50511. Is there in the invite. It is there in the invite, all this information. Okay, let's write it neatly so that it's easy to comprehend. It's easy to comprehend. So the first thing, the controller is going to send an invite to the provider. The invite is going to say from 3636.466, which is this number, and the IP address at the IP address of the controller. Let's say 192.168.1.2. But because we are going through the internet, the firewall is going to change this IP address using SIP ALG, which is SIP Application Layer Gateway. SIP ALG means application layer. we will talk more on the CPLG. So the CPLG is going to look at this, and then it's going to change to the public IP address of the internet for which is feeding the controller. Maybe the public IP address could be 169.255.82.15, and then obviously there's a port here which is port 5060, and it will be port 5060. And then in the invite again there is a 2 part of the invite which is 7383.1039 at the public IP address of the provider. In this case it could be 168.167.45.22, and again at port 5060. Then this is 1, 2, this is all in the invites, and in the invites there is an SDP part which has codec, it has RTP port. In the codec is going to propose, probably G711A, probably G711 YOLO, depending on what you configured it to send in the proposal. And it's going to say we are going to open an RTP path using port. Probably it's going to choose at random from this range of ports for Mitel. Probably it's going to choose 511, and then it's going to say talk to me on this port, and it's going to put the IP address of the phone. Maybe the phone's IP address is 192.168.1.11, so it's going to put 192.168.1.11 and a port here. So if there is a file, it is the duty of the file to change this 192.168.1.11 to the public IP address on the file, because this private IP address cannot be routed onto the internet, and this here is an obvious cause of no audio. If this IP address goes out as 192.168.1.11 to the provider, and the provider sees this IP address in the SDP, there is going to be no audio. Media is going to be set up, but because there's no way this private IP address can be routed over the internet, there will definitely be no audio. So this is the invite that Mitel has sent out to the provider. So what the provider has to do next is to extend the invite to this guy here, and it also that's when it's going to say trying. It's going to send this message back to Mitel. It's going to say ringing, and when this guy picks up, it's going to send an SDP acknowledgement. It's going to say SDP OK, and Mitel is going to send an SDP acknowledgement. So in this SDP OK, the provider is agreeing to use this codec, probably of G711A, and it's also going to say in that acknowledgement, it's also going to put its own RTP it's going to also put its own RTP port. But we know that for this provider, its RTP ports are from a range of 10,000 to 65534. So it's just going to pick any port here at random, and it's going to, okay, let's clean the board, and so we are back to it. Mitel send an invite, and this is a continuation. the invite has got an SDP inside it, an SDP that Mitel is proposing to the provider. Then the provider is going to send these messages like trying, like ringing, and when there's an answer, it's going to send an SDP. It's an acknowledgement, an SDP ACK. In this SDP from the provider, it's also going to have a codec selection, which is it is agreeing to say, okay, I saw you said you can talk to me with G711A. I am agreeing. You can go ahead and use that. And it's going to say, let's open up an RTP media stream with me, which is my IP address here, 6168.168.45.20.22, and it's going to choose a port, maybe 65530, because the provider has got an IP port range of 10,000 up to 65534. So when this has been done, the SDP has been negotiated and agreed upon to say this is what is going to happen. We are going to go to this next step. So again, I'll recap. There is an invite with SDP in it, and eventually the provider has responded with also an SDP OK, which is an acknowledgement. And then the next step is that the information that was contained here it said RTP, the IP address of 192.168.1.11. We said it shows port 50511. This is what was said in here, that use codec G711A and create a path to 168.1.11 on port 50511. And the provider responded to say, I am fine with using G711A, and let's form our RTP media path to 168.167.45. Probably going to say .23 on port probably 65531. So what then this means is this guy is going to at a high level, it's going to be 168.167.45.23 port 65531, and we are going to form a temporary media channel. This is going to be like a pipe where we are going to have our audio. Our audio is going to be in this temporary pipe, this RTP UDP. And at the end of the tunnel is going to be this IP address. So this IP address, if your file is not able to change this IP address into the public IP address of the internet on the firewall, so that is routable over the internet, we are going to have this person, the audio is going to be able to, let me just change the color here. This person, when this person talks, so this is a person, when this person says hello into the phone, this hello is going to go, this guy is going to hear it, and this guy is going to reply back. This guy is going to say, how are you? and this hour is going to come here and is going to die on the firewall, because if this IP address is 192.168.1.11, the ISP cannot route this, so it's just going to drop this packet, and this person is not going to hear the response from the external part. The internal part, this is going to hear, but this one is not going to hear. A is not going to hear, but B is going to hear, because the media packets can reach him, but when he responds, his packets are either being dropped by the ISP on his side because there is an IP address that they can't route, or it is actually reaching the firewall and the firewall doesn't know what to do with this packet because it is probably because of the SIP LG. It is probably translating the ports, so that when these two parties have agreed to say we are going to talk on this port, maybe your firewall is changing this port probably to 60511, but this is not a port that has been agreed in the SDP, and it's going to send audio to this port, and this port in the meantime does not exist, so the packet gets dropped, whereas the phone is listening for audio on port 50511. There we have also created a one-way audio. So I've just cleaned the board. So the causes of one-way audio are: number one, net on the firewall or router. By netting we mean when we are involving the internet between the SIP trunk provider and the My Voice business. If we are involving the internet in between, then what is bringing internet to our My Voice business or into our lane should be a firewall or a router or some other device, and that device should have a public IP address on the internet facing side. If this is our firewall, we should have a public IP address, and this public IP address should have a port forwarding or port 5060 to the MIVB, and it should be able to allow the setup of the RTP tunnel, the media path between the calling number and the called number, the calling or the caller and the called. It should be able to allow the IP for this user, the IP address. It should be able to change it from a private IP to a public IP. It should be able to maintain the RTP port if it was negotiated at 511 this side. When it should not change, and also the RTP ports negotiated from this side if it was 65531, it should also not change. The firewall should not tamper with this. These two ports should remain as they are. If the ports are changed by the firewall, then we are going to end up not having any audio. If the firewall blocks the port, maybe it's not changing it, but the firewall rule or policy, it is blocking access for this port or this port, then we are going to end up not having audio. And also if there is a codec mismatch we are also going to end up not having audio. But a codec mismatch is very rare because of the negotiation that goes between. The other end proposes a list of the codecs that it supports, a list like codec 1 up to probably, maybe if it has 5 codecs on it, is going to list its codecs, and the other part is going also to bring its own list. Let's say list A and list B for the other side. It's also going to list. Then they are going to find which codecs do they have in common, and from those codecs that they have in common, they are going to agree on which codec they are going to use for each call. Each call goes through the same process. When they agree on a codec, then they will talk. We can only have a codec mismatch if list A and list B don't have any codecs in common. And in most cases, if these codecs if there are no common codecs in the list of A caller and the called party, which is party B, normally the call is rejected. Normally some SIP trunk providers will reject a call based on it not meeting its criteria of codecs. So bear in mind that also a codec mismatch can also cause an audio issues. Now let's jump onto the controller, where we are going to look at how we troubleshoot or investigate. How we are going to investigate So we are going to log on to my voice business system administration tool. System administration tool. And we are going to go to maintenance. Maintenance command. The first command that we are going to put is called CCS trace. So we are going to use the CCS trace. We are going to enable the trace, and then we are going to make a call. Once we make a call, the trace is going to show us here. This window is going to populate, is going to be filled with traced information. Then when we are happy with our test call, we are going to disable CCS trace, and we are going to copy. We are going to say control A to highlight all, and then we are going to say control C to copy everything. Then we are going to open Notepad++, and then we are going to say control V to paste the traced information into the notepad. Then we are going so this is a troubleshooting way number 1. Then we are going to discuss way number 2 when we are done with way number 1. So let's go ahead and do way number 1. And I'm going to say CCS trace enable continuous, and then I'm going to submit, and then I'm going to make a call. You can see these are traces that have come in. So the call is not being answered, so I'll just end the call. So this CCS trace was just meant to show us that calls are coming into the system. Calls are coming onto MIVB. As we can see, we had a call from 3636466. This was the caller who called this destination. This is the code number, which is 1000. 1000 is the code number. So this number came in as a 4-digit, although the full number was 365. But because it's a DDI number, this number got stripped, and then our 1000 came in, and then 1000 was called, but there was no answer. But because we are tracing, we are doing SIP trunk, we are tracing a SIP trunk, we are going to put another command which enables us to trace SIP trunk, which is way number 2. So let's go ahead and do that. The way number 2 works, let me just clear this. What we are going to do, we are going to use SIP tail on. This is the command that we are. Once we do that, this window again is going to be filled with traces. Once we are happy with the traces, we are going to put a command SIP tail off. And so once we do that, once we stop the SIP tail, we are also going to now put Control A to highlight everything, then Control C to copy everything. We open our notepad ++. We are going to say Control V to paste everything in there, and then we are going to analyze. Let's go ahead and do that. We are going to say SIP tail on. I submit. This command requires a confirmation. I say OK, and then I make the call again. You can see the terminal is now filled with traces, and of course there is no answer. I am going to hang up. I am going to hang up, and then I'm going to say SIP tail off and submit. This command requires confirmation. I say OK. Then I come into this window. I say Control A to highlight everything. Then I'm going to say Control C. Then I am going to open Notepad. Notepad ++. Notepad ++. And I'm going to say Control V. And once I do that, these are our SIP messages. Let's look for our invite in here, or I can just search for invite. So you can see here we got an invite here. We invited 1000 at this IP address. So this was our invite, because it was an incoming call. So we expect the invite to originate from the service provider, from our provider side. So our provider, in this case, our Mitel controller, its IP address is 10.150.4.100, and our provider IP is 10.251.251.24. So we are going to see an invite, and it's going to say invite from, let's look at this part, from 3636. It is saying from 3636, this is the calling number, at 10.251.251.24, this is the IP address of the service provider, and it is a 2. It is inviting 1000, which is the extension number 1000 on Mitel. And it is inviting it at the IP address of the controller. And you can see here it has put the IP address of the controller. And here we've got our SDP in the invites. It is saying talk to me on PC. It has a list of its, it has submitted a list of its codecs. Let's have a closer look there. It has said PCMA. This is the, and we know this means G711, G711 A-low. PCMU, we know this means G711 U-low. And it has G729, it has G723, it has G726, and so on and so on, as its codec list. And it is saying you must open a RTP media or audio path with 10.251.251.25, on which port? Let's have a look at the port number. Okay, the audio, the port is, come on, the port is here, 35774. So this is what the provider said to Mitel. Open a media path between 10.251 251.25 on port 3774. And Mitel should also respond to this SDP with its own SDP, with its acknowledgement and its IP and port. Let's have a look at that. Since this call was not answered, I do not see any response. I only see the call clearing before we get any SDP acknowledgement from the Mitel side. If we scroll down, you can see that eventually I had to hang up the call because there was no answer, and then there was an acknowledgement for hanging up the call. So had this call been answered, we would then see the SDP communication from the Mitel side back to the provider in response to the proposed SDP by the provider. And then we could see what IP address and port did Mitel put, because we saw the port that the provider put 35774, and it was 10.251.25. So we're also going to see what Mitel was also going to respond with. Okay, so now let's just continue to another way number 3, or method number 3. Let's clear our here. So way 3, or method number 3. Method number 3 involves SIP TCP dump. So we are going to cause the Mitel controller to do a TCP dump, and then it's going to save a file that we are going to collect with the file transfer application. With the file transfer application, such as FileZilla or WinSCP. In our case, we are going to use WinSCP. This is what we are going to connect to the controller, and we are going to navigate to root Vimeo folder, and this is where we are going to get our PCAP file, which we are going to open with Wireshark when we do our analysis. So we said we need number 1 WinSCP, and number 2 we need Wireshark itself. So we need these two for our method number 3. So let us start by opening up WinSCP, WinSIP. I'm going to open WinSIP. Let's just do this. We are going to open WinSIP2, our controller. We log in with root. When it's my voice business 9, when it's my voice business 9 plus, we log in with SFTP, the IP address of the controller, and username root. Username root, and the password is the password that you set. Normally it is your password for the server manager. But when this is my voice business 8 minus, which means it would be 7654321, you log in with FTP. We change this to FTP, and the username here is system, and the password here is our system password. So when our controller is on release my voice business 8, we come and change here to FTP. But in our case, this controller is my voice business 9. We are going to use SFTP with the username root and the password. I'll put the password, and I am going to log in, and we are going to navigate to the root folder, and we are going to look for the Vimeo folder, and this is where our PKIP file is going to be. Right now it's empty, we don't have it, but once we generate a TCP dump, it's going to come here and sit here, and then we are going to transfer it from the controller to my desktop, and my desktop I'm going to put it in a folder called logs. So now let us go back to the controller, and we are going to put this command SIP TCP dump on, and we are going to submit, and then it's going to say SIP TCP dump started. Then I'm going to make the call again.
Good morning.
Good day, ma'am. How are you? I'm okay. Can I please speak to IT? IT. Okay, alright. I'll call it. Okay, alright. Thank you. Says bye. So I have made the call. So I have to go and say TCP dump off, and I submit. Note that when you are running this command, when you have stopped the TCP dump, it's going to say SIP TCP dump stopped. And these are the only two things that you are going to see. This one will not be there. These ones are just there from our previous command, which we did not stop, which I'm going to stop now. CCS trace disable. You must make sure when you run a command, when you are done with it, you turn it off. So in our case, we have stopped the TCP dump. We go back to our WinSCP, and we are going to refresh it. As you can see, there's no PKIP file here. We are going to refresh. Once we refresh, this file has come up, this one. So I am going to move it to I'm going to copy it to my desktop logs file. Then it comes and sits there. And if I navigate to my desktop, to that folder, this is the Wireshark PKIP, and this call was answered. So let's investigate. Let's take a look at what we have there. I'll come here, I'll go to my desktop, I'll create a folder here. I want to move it to here. So I'll open it with Wireshark, and we are going to see the first thing is an invite, and we are going to expand this. And we are going to go up here where it says telephony, and we click on telephony. We are going to go to where it says VoIP calls, and we are going to highlight this, and we are going to say flow sequence. So you can see the call came in from the provider. Let's have a look. This is the provider. This is Mitel, and this 24 is the signaling IP for the provider. Is equal to signaling, which is there. Which we set up the call setup, signaling for call setup and tear down. And this is also what we use for negotiating our SDP. So we saw from the provider there is this invite with an SDP in it, and it is from 3636463,466, and we can actually go ahead and have a look at what was in that invite, what is contained in this invite, by clicking on that invite there, and we come here and we go and we look at here at the details. You can see it has a source. This invite came to us from 10.251.251.24, which is the signaling IP for the provider, and it was sent to a destination which is 10.150.4.100, which is the IP for our Mitel, and the source port was port 5060, and the destination port was 5060. So in short, what we have is 10.251.251.24 port 5060 talking to 10.150.4.100 port 5060. And take note that between these two there is no internet. This is like a VPN connection, no internet. So we are not worried about fire or anything else there. So let's now continue to inspect further. What else are we seeing in here? We can see the invite. It was looking for extension 1000 at the IP address of the PBX. You can see here it invited 1000, and if you scroll to the bottom, we can see the SDP, session description protocol. Session description protocol is SDP. So let us have a look at what the SDP is saying to us. Let me move this guy out of the way and let us do this. It is saying this message came from 10.251.251.24 and it is saying talk to this IP address. We are going to open a media RTP media path, media or audio path with 10.251.251.25. Note that the provider is 10.251.251.24 for signaling and 10.251.251.25 for media. So it is now saying for media, use this IP address at port RTP port 36404. And we go back to our main screen where we had the Mitel replying to the provider to say, I'm trying, the phone is now ringing. When the call was picked up, then Mitel responded to the SDP. Let's see what was in the SDP when Mitel responded. It said, this okay, let me change the color here. Let's take green. This IP now. This IP now is a Mitel IP. It is saying open a media path to 10.150.4.117. 10.150.4.117. This is the IP address of the phone itself, not the Mitel controller. The Mitel controller's IP address is 100, but 117 is the IP phone, and it's saying open media path to port 50466. 50466. So you can see eventually it's now saying you two talk to each other on this, should talk to this on this port. Let me simplify that. Let me simplify that for you. So what we are going to end up with is 10.251.251.25 port 36404 talking to the Mitel IP phone, which is an IP address of 10.150.4.117 on port 50466. So we are going to have this. If this is successful, we are going to have our full audio. But if one part is changed or this port is blocked, we are going to have one-way audio. Or if this IP address is changed, while we are expecting audio to go to 117 and it is being changed to go to another, maybe 120, we are not going to have audio. or if this IP address is also changed here to another IP address which we don't know, which was not in the SDP, we are going to fail to get audio. So it is very, very important for you to confirm that what has been negotiated in the SDPs here, it is exactly what is happening. So investigate if there is something that is changing the information that has been negotiated here. It could be something in the form of a firewall. Check what is the firewall doing to this information. You can also run a trace on the firewall and also compare the traces that you see on the file. If they are the same as the traces that were, definitely you will see a change and then you correct it. And you can also ask the provider to do a trace on their side, and then you compare your traces and see where the information is changing. Obviously, if there is no audio, you are going to see a discrepancy which you should know how to address. If it is not, or if it is, then you definitely know what is wrong and you address accordingly. Moving on. So we say, okay, let's go back to using red. Let's go back to using our red color. Audio challenges can be caused by net on the firewall router. It can be caused by RTP ports being mistranslated or being changed or being dropped. RTP ports being translated, which means they are being changed, or they are being dropped, which means they are being blocked by whatever device is in the middle. Or we can have the endpoint IP addresses themselves, which could be the IP address of the PBX, which is our Mitel, or it could be the IP address of the phone itself, or it could be the IP address of the provider, also being changed or dropped. It can also be translated, which means changed or dropped. This will also cause us audio issues. Or we could have the absence of a public IP address. When we are routing over the internet, and we expect to have a public IP address. And then the public IP address is not available. It's not available. We don't have any public IP address at all. Or we are using a wrong public IP address. So we also have to confirm this on our firewall. Or we could be having an issue with SIP ALG on our firewall or router. SIP ALG is a friend and enemy at the same time, depending on whether I want it to be a friend or an enemy. There are scenarios where we need SIP ALG to be disabled. When we've got a static static one-to-one net. We don't need CPLG enabled. But when we are doing port overload, okay, let's say overload, we will need CPLG enabled, because we've got an IP address that we've got a single public IP address for both a PBX microcontroller and phones and phones. So what do I mean here? Suppose we've got our firewall here, and we've got a public IP address here, which is, for simplicity, I'll just say 4.4.2.2, just for interest's sake. And we've got our microcontroller here. Its IP address is 192.168.1.2, and we've got an IP phone here. Its IP address is 192.168.1.12. So for this method to be able to reach the internet, to be able to navigate the internet, it needs to come through this public IP address, and is going to be NATed to be 4.4.2.2. Also, at the same time, this phone needs to go to the internet, because this phone needs to go to the internet in order to be able to talk to this guy who is out, and this needs to go to the internet to be able to talk to the provider. So this will also need to use 4.4.2.2, but we can't have two devices using the same IP address. So this is going to lead us to use NAT port translation, or what we call NAT overload, where if this is communicating, the PBX is communicating as 168.1.2 on port 5060, and this is communicating as 192.168.1.12, maybe port 50511 to here. So when it comes to the firewall, when we are changing this part here to 4.4.2.2, we don't want this port to be changed. But the way NAT does that, it wants to change this and assign it its own port number, so that it can be able to tell that this is the traffic that has come from this source. But we don't want this to happen. But we want this part to be changed, only the IP part to be changed, and we don't want the port part to be changed. So this is where we want the help of SIP ALG. So we want ALG to be enabled. But if it is such that we've got a dedicated public IP address for the microcontroller, probably it is 4.4.2.3. It is a one-to-one NAT with the PBX on port 5060. Then in this case, we don't want CPLG, we want it to be disabled, because it's going to change one of our either IP address or the port, but we don't want that changed. So in this case CPLG becomes an enemy and we disable it. Okay, moving on. You can see here, this is the PCAP that we took, but we are supposed to delete it so that we don't fill up our controller with PCAPs, packet capture. Each time we do a packet capture, they add up, they load up, so we should just do a cleanup after we are done. So we are going to come here and we are going to say SIP TCP dump clear, and we submit. If we go back, it says TCP dump files cleared. If we come into here and we refresh in WinSCP, we can find that it is clean now. It is cleared. Then we can close that. We can say OK, and we clear and we log out. So moving on. So we can see that Mitel will set up a call through invites, and with SGP it's going to set up a call and let the call, when the call has been answered, there is going to be a path that is set up between the caller and the called. This is for media. So if you have 10 phones, making calls at the same time to different destinations, we are going to have another tunnel here, and so forth, and they'll be talking to some people who are external. So we are going to have so many media paths being set up and tiered down as the calls get completed. So this is not a recommended practice. Mitel does not recommend you to connect a SIP trunk directly to my voice business without MBG, without my voice border gateway, because the my voice border gateway is going to act as a SIP proxy. It is going to act as a SIP proxy, such that all this is going to be one tunnel. At high level is going to be one media tunnel instead of so many. Okay, let's simplify it. Invite an SGP. We are going to have a call setup, and we are going to have an MBG. Once the call has been established, the call is going to move to the... Okay, let's do this. MBG. So when you have the MBG, the invites are going to go through the, and the media is going to be Okay, let's put media. So you can see if we have another phone here and another phone here, all of them will be and then if you have a firewall, the firewall will talk to the MBG only. It doesn't talk to the other devices here. It is only between the firewall and the MBG. Let us take a look at a call that is done when MBG is in the picture. So we are going to log on to the MBG, and unfortunately this tutorial is not going to show you how to configure an MBG for connecting a SIP trunk. We are only going to go to an already configured SIP trunk, and we are just going to investigate and take a trace. We are just going to investigate audio there. There's going to be another separate tutorial which is going to demonstrate how to configure a SIP trunk on an MBG. So we go to the MBG, we go to troubleshooting diagnostics, we are going to run a packet trace. Let's just delete whatever is there. We delete that, let's just start with a new packet capture. I enable packet capture there, then I make a call.
For calling.
Good day, sir. How are you? Is that IT? Okay, do you know which extension is for IT? Okay. Okay, I'm just made a test call. I am on hold. Let's just wait to finish this call, then we will look at it. 5020. Okay, thank you, sir. Okay, cheers, bye. Okay, I've completed the call. I'll turn off the trace and I can go to this global. For now, I'm interested in the global. I will download it. Let's wait for it to finish downloading. Okay, it has finished downloading. I'll open it. So there's a lot of traffic there. I can just filter it by typing SIP here and enter, because you are interested in SIP traffic. there is SIP traffic. Then I can go to telephone, VoIP calls. I'll look for the call that I made, which is this one at the second. I'll go to flow sequence. Okay, let me just take these two flow sequence. Then I will explain. Let us explain what we are seeing here. We are seeing this as the okay, let's go back to our red. We've got this IP address being our provider. We've got this IP address being our MBG. We've got this IP address being my voice business. And somewhere here is our phone. So we got, this was an incoming call, so we are expecting an invite from the provider. So the provider came with this invite. Let's check it out. So this invite came in here saying it was from source. This source is the provider IP address, and this is the source port 5060, and it was destined to our MBG. This is the IP address of our MBG, and at port 5060. So we've got the MBG and we've got a firewall, and the MBG is working hand in hand with the firewall. The firewall is going to translate to change this IP address into a public IP address, this private IP address of the MBG. And we were looking for extension 5092 at the IP address of the MBG. And let's scroll down further to see what that information is for us. So the provider signaling IP was equal to 168.167.74.52, and it is saying create a media path with 168.167.74.54 on port 5 on port 4 on port 4 6 4 12, and the list of the codecs are here. We've got G711, we've got ALO, we've got G711 ULO, and the list goes on. So let's see when then this was from the provider towards Mitel. Let's see how Mitel responded. So it responded here where it said SDP OK, SDP G711. It accepted G711. Let's go and see what the details were. It said port 72. It said IP address 172.174.3.101, port 27028. And you can see that this is the IP address of the MBG, and we don't see the IP address of the phone. You remember in the previous, when we were looking at my voice business, this would have been the IP address of the phone. But right now it is putting its IP address here. So it is saying set a media path between this IP and port and itself, the MBG, at this port 27021. And you can see that the MBG has its own range of RTP ports, which are different from the, when we have connected the SIP trunk directly to the my voice business, the RTP ports are 5000, 50,000 to 5511. But when we use MBG, they are around 22,000 something up to 29,000. I have to confirm this, but they are around this range. So now let's pursue further. Let's see what else can we find in the trace. Okay, let's open the other trace. Let's open the other trace. The signaling, this one. Let's start that one. Okay, so this is our trace on the MBG. We said this is our provider, and this is our MBG, and this is our MIVB, and this is our phone. So this is the invite. The invite is from the provider to the MBG. From the MBG, the invite went to my voice business. From my voice business, it went to the phone, and then it came back. Then there was trying sent from the MBG, which is the one which was sent by MIVB, and then through the MBG back to the provider. And when the phone was ringing, the MIVB sent ringing to my voice border gateway. My voice border gateway sent ringing back to the provider. The provider acknowledged to the MBG. The MBG acknowledged to my voice business, and that acknowledgement, the MIVB said okay to the MBG, and the MBG extended the okay to the provider, because the phone was picked up here, answered. It was answered, picked up or answered here. So this was the conversation being trapped on the MBG, because now the media is between the MBG and the provider, so we are able to trap the audio. But remember, if there was no MBG, this audio would have been going through from the phone to the provider, and because we were tracing on the my voice business only, would not see these RTP packets, because for us to see them, it means we would have gone to put a trace on the phone itself. But because our media now is passing through my voice border gateway, because my voice border gateway is the proxy we are now able to see the media and we can trap it. We can see this is saying RTP, that's the media, this is the media, this is the media, this is the, we can actually play back the media. And by coming to here, we select the media that we want to play and we can actually play it, and we can actually hear it.
Good day, sir. How are you? Is that IT?
So what we are hearing now,
Okay, do you know which extension is for IT?
It is me speaking. This is the incoming. This is the caller. This part is the caller. It is me. This is my audio. We are only listening to the leg that is coming to from the provider to the MBG to the MIV to the phone.
Okay, I'm just made a test call. I am on hold. Let's just wait to finish this call.
Let's do this.
And we will look at
this.
5020. Okay, thank you, sir. Okay.
Let's do this. So if I wanted to hear what the other guy was saying, I can come here. Let's listen to this one.
Thank you for calling. I'm good, and you?
This is the side of the phone. Going to.
Hey, let me check some for you.
MBG. Going to the provider. Let me see if I cannot open them together at the same time. At the same time, I can. This is, let me see. Okay, for now, that is all for now. Thank you for watching. If you have any questions, comments, please feel free to share in the comment section. Thank you for watching. Goodbye.